Welcome back, everyone. In this video, we will be covering the fourth part of Lecture 11. The topic is the binomial option pricing model. Yep. So prior to the break, we priced European call and put options using the binomial model. We'll now discuss two auxiliary topics. The first is ways to exploit arbitrage opportunities. And the second is a note on how to interpret this option delta term that we've derived, this delta. Okay, so let's get started. We will begin with call options. So we've learned so far that the price of the call option should equal the price of its replicating portfolio, where the replicating portfolio is comprised of delta shares of the stock and beta shares of the bond, delta and beta. Okay. We now want to ask what happens if the actual observed market price of the call option differs from the price of the replicating portfolio. Okay? If we remember back to forwards, we did something similar, and we learned that if the price of the call option differs from the price of the replicating portfolio, then there must be an arbitrage opportunity. We derived the replicating portfolio to exactly match the payoffs of the call option, and hence their prices must be equal. Okay, so if the market price of the call option does not equal the price of the replicating portfolio, there are two possible scenarios. The first is whenever the call option price is too high, or whenever the call option price exceeds the price of the replicating portfolio. This is the price of replicating portfolio. Okay. In this case, there will be an arbitrage opportunity, and it's because the call is too expensive. To implement the arbitrage, what do? We sell the call option, we're selling high, and we buy low. We purchase the synthetic call option, which is just the replicating portfolio. We long delta shares of the stock, and we short beta shares of the bond. Okay. The payoff to this portfolio at time capital T of long the replicating portfolio, short the call option, will be 0 at time T. However, this portfolio is going to generate positive profits at date 0. Okay. There's also another scenario. So suppose that the call option price is too low. That is, the price of the call option falls below the price of the replicating portfolio. In this scenario, there's also another arbitrage, and the way we exploit it is by buying low and selling high. The call is too cheap, so we buy the call option, and the replicating portfolio is relatively too expensive in this sense, so we sell it. We're going to short the stock and we're going to long the bond. Okay? So the idea is very simple. By no arbitrage, the price of the call option must equal the price of its replicating portfolio. If it doesn't, then there's an arbitrage, and we can arbitrage this by constructing a portfolio that buys the thing that is cheap and selling the thing that is expensive. The payoff to the arbitrage strategy will always be 0. However, it will generate positive profits at the date of origination. To make sure we understand this concept, we'll do a practice problem. I'll give you a minute to look over the problem, and then I will go ahead and solve. Okay, problem statement is as follows. We're in a binomial world. There are two dates, 0 and 1, date capital T. There are two states at date 1, which is the future, U and D, the up state and the down state. Consider Zoom stock, Zoom video, where we might all know about this nowadays. Zoom is a non-dividend paying stock, and today's price of Zoom is $100 per share. At date 1, Zoom's payoff will depend on the state of the world. In the up state, the price or the payoff will be S sub U equal to 125. In the down state, the price will be S sub D equal to 80. Continuously compound risk-free rate is 0%. Okay? A dealer is going to quote you. You're going to be interested in Zoom, in particular European call options on Zoom. You go to a dealer, he's going to quote you a price of $15 for a European call option on Zoom. That's at the money. It's got a strike of 100 and a maturity of 1 year. We want to answer 2 questions. First, based on this market price that the dealer quotes us, is there an arbitrage opportunity? And if so, how would we exploit it? Let's start by writing down our inputs. We'll use the binomial tree. There's 2 dates, 0 and t. There are 3 assets in the model. Okay, the model starts at date 0. There's 2 states at date t, either the U state or the D state. There are 3 assets in the model. Okay, there's a stock. This is Zoom stock. It has a price of $100 per share today. There's a bond, B0. It has a price of e to the negative r, which is 0% times 1. So the price today is just 1. And there is a call option who the market price tells us is equal to 15, but we want to solve for what the no arbitrage price should be. Okay, and then we want to compare the two. The payoffs to the stock are as follows. We'll consider each asset separately. Payoff to the stock depends on the state of the world. In the up state, the stock has a payoff of SU equal to 125. Okay. This implies that the gross rate of return, U, on the stock is just SU over S0 from the binomial model, which is 125 over 100, or 1.25. This is 5/4 fractions. Okay. In the down state, the stock has a payoff of S sub D equal to 80. This implies that the gross rate of return in the down state D is equal to S sub D over S0. It's equal to 0.8, or if you want to write it in fractions, that's just 4/5, the inverse of U. Okay. The bond's payoff does not depend on the state of the world. In the up state, it's BU equal to 1. In the down state, it's BD equal to 1. This is because it's assumed to be risk-free. The final component of the model is the payoffs to the call option in the up and down state. The strike on the call option, we'll write it up here on the top, is K equal to 100. The payoff to the call in the up state depends on the stock's payoff. It's equal to the max of SU minus K and 0. Plugging in our inputs, 125 minus 100, SU minus K and 0. This is equal to the max of 25 and 0, which is 25. The call's payoff in the down state is denoted CD. It's the maximum of the stock price minus the strike price and 0. Stock price is SD. It's equal to 80. Strike price is 100 still. 80 minus 100. Maximum of minus 20 and 0 is 0. So the call payoff in the down state is 0. Call payoff in the up state, 25. Call payoff in the down state is 0. To solve this problem, remember what it's asking. Is there an arbitrage opportunity? If so, how would we exploit it? Well, to know whether or not there's an arbitrage opportunity, we need to compare the quoted price over here, C sub 0 market, to the no arbitrage price. We don't know the no arbitrage price yet. We're going to need to go out and calculate that. Okay, we'll do this on the following slide. Okay. So in part 1 of this problem, we're going to calculate the no arbitrage price. We know the formula for the no arbitrage price. It's going to be equal to the delta CU minus CD over S0 U minus D times S0, and then plus the beta CD dot U minus CU dot D over U minus D times e to the negative r times t. Okay, or this is just B0 here. Plug in our inputs. CU is equal to what? It's 25. CD is equal to 0. S0 is equal to 100. U is equal to 5/4. D is equal to 4/5. S0 is equal to 100, today's price. The beta is given as follows. CD is equal to 0. U is 4/5 minus CU, call payoff in the upstate, 25 times D, 4/5 over U minus D, 5/4 minus 4/5 times e to the negative RT. This was just 1. Get our calculators out. Do a little quick computation here. I've already got it solved. Check my work. It should be $11.11. The no arbitrage price of the call option is $11.11. Okay. So if the call price in the market is equal to 11.11, then it is indeed, there's no arbitrage in the market. However, if it deviates from C0 at all, then there will be an arbitrage. Okay. Recall that the market price, let's talk in part 2. Recall that the market price on the call option was equal to $15. Note that this is greater than $11.11, which is the no arbitrage call price, C0. And so yes, since these two deviate, yes, there is an arbitrage. Okay. How do we exploit it? Okay, we exploit it by buying low, selling high. We exploit by buying low. Buying low is equivalent to buying the call option. It's cheap relative to the market. Buying the replicating portfolio. Okay, replicating portfolio is cheap relative to the market price, and selling the call. Okay, this portfolio will have a 0 payoff at date T, but it'll generate you positive profits of, you can even write them out, it's going to generate you profits equal to $15 minus $11.11. Okay, it's a little under $4. What is the replicating portfolio? The replicating portfolio is long delta shares and short beta bonds. Delta is given from up here. Okay. We can calculate what it is. It's 25 minus 0 over 100 minus 5/4 minus 4/5. Okay. This is something like 0.556. And beta is given by the amount over here. Okay. We just calculate it out. 0 times 5/4 minus 25 times 4/5 over 5/4 minus 4/5. Okay, this is going to be minus 44. Okay, so what the replicating portfolio is going to do, you're going to short the call option in the market. You're going to go out and buy about half a share of Zoom, and you're going to sell 44 shares of these bonds. Okay, this portfolio combined with the call option will have 0 payoff, but it'll generate positive profits and arbitrage. Okay, so that's call options. What about put options? The logic is essentially exactly the same. We know by no arbitrage that the price of the put should equal the price of its replicating portfolio. If these two values differ, then there's going to be an arbitrage strategy. And there's just two possible cases for this arbitrage. One is where the put is too expensive, and the second is when the put in the market is not expensive enough. Okay, let's consider both cases separately. First, suppose that the put price exceeds the price of the replicating portfolio. Okay, put price P0 exceeds the price of replicating portfolio. In this case, the market price of the put is too expensive relative to its no arbitrage value. So the way you're going to exploit this is you're going to sell the put option. Okay, you're going to sell high and you're going to buy low. You're going to buy the replicating portfolio, which remember that the replicating portfolio for a put is always shorting stock and longing a bond. The second scenario is if the put is too cheap relative to the no arbitrage price. That is, the put price P0 is less than the price of the replicating portfolio. In this case, we exploit the arbitrage again by buying low, selling high. We buy the put, we sell the replicating portfolio. Okay, so we buy the put, we sell the replicating portfolio, and shorting the replicating portfolio is equivalent to longing the stock and shorting the bond. Okay, same exact logic as the call, except just kind of flipped in reverse when we think about the replicating portfolio. Okay, so I'll let you look at this question for 1 second. It's basically the same exact setup as before, except now we're going to examine whether there's an arbitrage opportunity for a put, and we're going to ask whether we can exploit it. So I'll give you a second to read this, and then we'll work through it. Okay, so the problem is the same exact as before, except now we're dealing with a put option. We're still in a binomial world. There are 2 dates, 0 and 1. Everything that goes on at date 1 is not known yet, but there's 2 possible states, up state and down state, good and bad. We're interested in Zoom stock still, doesn't pay dividends, $100 per share. Zoom, the payoff on Zoom is dependent on the state of the world. In the good state of the world, the price is SU, 125. In the down state of the world, it's $80. Continuously compounded risk-free rate still 0%. We're interested in put options on Zoom, European ones. They're at the money with a strike of 100, maturity of 1 year. And a dealer's going to quote us a price on a put option of $10. What we want to do is we want to compare the dealer's quoted price to the no arbitrage price. Ask, is there an arbitrage opportunity? And if so, how should you exploit it? Okay, so the model that we have for our inputs is the same as the call, so we're not going to draw the binomial tree again. However, the key thing that we do need to add to the model from before is the puts payoffs. So let's work with those. The strike on the put is 100. Okay, and we need to know what the puts payoffs are in the up state of the world, PU, and the down state of the world, PD. Okay, the puts payoff in the up state is given by the maximum of the strike price minus the stock price in the up state of the world and 0. In the down state, it's equal to the maximum of the strike price minus the stock price, but this time in the down state of the world and 0. Let's plug in our inputs in both cases. In the up state, the puts payoff is equal to the maximum of the strike, 100, minus the stock's price in the up state. This is from the last question, 125 and 0. This is the max of negative 25 and 0, which is 0. In the down state, the puts payoff is the maximum of 100 the strike minus 80, the stock price in the down state, and 0, which is equal to 20. Here, maximum of 20 and 0 is 20. Okay. Now to solve the problem, what we need to do, we want to ask, is there an arbitrage opportunity based on the dealer's quoted price of $10 for a European put? To answer this question, we need to go on, we need to calculate the no arbitrage price. Okay, we could just use the formula, but it's probably easier when we think of the second part on how to exploit it to just go out and calculate the delta and beta, and then go out and calculate the replicating portfolio from these relevant shares. So we start with the puts delta and calculating that. The puts delta is given by PU minus PD, change in the put price, over the change in stock price, SU over U minus D. Plug in our inputs. This is 0, put payoff in the up state 0, minus 20. Okay, over the initial stock price is 100. U, gross rate of return, 5/4, minus 4/5. What we're going to see is that this is negative. Once you plug this into your calculator, negative 0.44. So the replicating portfolio shorts 0.44 shares of the underlying stock on Zoom. The second part of the replicating portfolio is the bonds. What do we do with this money? Okay, what do we invest in? Okay, the formula for the replicating portfolio of number of bonds to buy is given by P sub D times U minus P sub U times D over U minus D. This is equal to plug in our inputs. P sub D is 20 times U, 5/4, minus P sub U, 0 times 4/5 over gross rate of return the upstate, 5/4, minus gross rate of return the downstate, 4/5. Get out our calculators, plug this all in, maybe use Excel if you want to use that instead. And what you're going to see is that this should be around 55.56 bonds. So the replicating portfolio, we short 0.44 shares. We long 55 units of the bond. Okay, and the price, the no arbitrage price of the put option is given by just the price of the replicating portfolio, which is equal to delta times S0 plus beta times e to the negative r times t. Plug in everything we have so far. Delta, we're shorting 44 shares at a price of 100 each. On the fixed income side, we're longing 55.56 bonds. Okay, we're multiplying that by the discount factor, the cost of the bonds. This is just one. We're going to find that the no arbitrage put price is 11.11. Just like the call, the no arbitrage put price is $11.11. Okay. Now to answer the question of whether there is an arbitrage, we need to go out and we need to compare this no arbitrage price to the market price. So we notice that P0 market is equal to, in the problem, $1.10. Price of the put that we're getting quoted in the market is $1.10. This is less than a no arbitrage put price of $11.11, which is P0 no arbitrage. So yes, so this implies that yes, there is an arbitrage. These two must be equal or else there is an arbitrage. Okay? The put price in the market is too cheap, while the replicating portfolio is considered relatively expensive. So we buy low, we sell high. We're going to buy the market put and sell replicating portfolio. This is equal to, you're going to sell delta shares, so you're going to minus 0.44. This is long 0.44 shares, and you're going to sell beta bonds, so you're short 55.56 bonds to exploit arbitrage opportunity. Okay. To summarize, we're given a market price for the put. We want to ask whether this price permits arbitrage. To answer that question, we go out and we calculate the no arbitrage put price. We have our formulas for delta and beta. We know that the put price has to equal the price of the replicating portfolio if there's no arbitrage. Plug in a bunch of inputs. We find the no arbitrage price is 11.11. Then what we do is we compare this amount to the market price. We see that the market price is too low, so we buy low, we sell high. Okay, so that wraps up the discussion on these arbitrage situations. We're going to end lecture 4, which is quite a long lecture, believe me, by talking about the option delta. Okay, delta was that thing that we've discussed many times here, delta. Okay. In general, the option delta is the number of shares in the replicating portfolio that is needed to replicate the option payoff. It can be interpreted as a sensitivity of the option price to the stock price. For a call, we calculate the option delta by taking the change in the call price. I'll highlight it here in green. By taking the change in the call price, CU minus CD, from the upstate to the downstate, and dividing it by the change in the stock price from the upstate to the downstate. SU minus SD, which is the same as S0U minus D. Okay. The call option delta measures the sensitivity of the call price to the stock. It's a difference in the movement in the call price relative to the movement of stock price. And hence, it's nothing more than just a partial derivative of the call price with respect to the stock price. For a call option, the delta is going to be positive. This means that the call price increases as the stock price increases. So as stock price increases by 1 unit, the call gets more in the money, so the call becomes more valuable. It also means that we need to long more shares. We need to long shares to replicate the payoff of the call, and we need to short bonds to finance this purchase. Note also that as the delta increases, the call is going to move more units for a 1 unit increase in the stock. And this means that we're going to need to hold more shares long as the delta increases. So as the sensitivity of the option price to the stock increases, we're going to need to hold more and more shares of the underlying in order to mimic the changes in the call price. The put option delta can also be interpreted as the number of shares needed for the replicating portfolio. It's the sensitivity of the put price to the stock price again. And again, it's just a change in the put price, so it's delta P over delta S. The change in the put price in response to the change in the stock price, or just a partial derivative, okay, of the put price with respect to the stock price. Tells you how much your put is approximately going to move if the stock price moves by 1 unit. For a put option, the delta is negative. This means as stock prices increases, puts become less valuable, okay, for an already struck put. And this is because it becomes more and more out the money. As the stock price goes up, okay, you hold the strike fixed, and the put is less valuable than it was just a second ago. Okay. It also means we need to short shares to replicate the payoff of the put, and we need to long bonds. Okay. As the delta increases, or excuse me, in absolute sense, as the delta decreases, what's going to happen is that the put is going to become more sensitive to changes in the stock price. So as the delta decreases, you're going to want to short more stocks and you're going to want to hold more bonds. Okay. So let's conclude. Lecture 11 was all about binomial pricing. We introduced the binomial option pricing model. It was extremely simple. It just assumed that the stock price can either go up or down in the next period. This simple model helped us derive exact formulas for call and put prices. Okay, we had a call price formula and a put price formula, which each was nothing more than the number of delta shares times the initial stock price that we own, plus the number of beta bonds that we hold times their price. Finally, we learned how to relate the parameter delta, which was the number of shares we needed to long or short, okay, to something called the option price sensitivity. It told us how much the option price moves for a 1 unit change in the stock price. So I posted a homework and quiz for this lecture. Please complete the homework in order to perform well in the quiz, and I'll see you in the next class.